And I'm going to actually define the scalability for the panel a little differently from what you may have seen before. Instead of defining it as number of transactions that you can process per second, I'm going to propose to use the definition of the number of transactions that you can finalize per second. Because whether you put them in the block or not, if they are not finalized in meaningfully short time, I don't think it's quite useful. So with that definition, I'm going to have my panelists to introduce themselves and state the goal of your project. What kind of number are you trying to hit from your project in that finality definition of the scalability? And where are you at? Are you at that number? Are you getting there? So please introduce yourselves. Let's start with Aleksandar.
So I'm Aleksandar Kuzmanovic. I'm a professor of computer science at Northwestern University. And more importantly, I'm a founder or co-founder of bloXroute Labs. So basically, to explain what we do in less than a minute, I hope, basically what we do is we provide a networking solution for all blockchains. So our goal is to scale up all possible blockchains. So to give you an example of how we do this, let's go to an example of, for example, YouTube. Everybody should be familiar with that particular example. YouTube today has 1.3 billion users, and at the same time it sends terabytes of data every single second. Okay? And so the question is, on the other hand, we have blockchains where sending 1 megabyte every 10 minutes is becoming the world's biggest problem of all times. So basically the question that we are trying to solve is how can we apply those ideas from the content distribution networks and put that in the blockchain space. And so basically what we are building is a trustless content distribution network to help scale all blockchains. Going back to the original question, which you were patiently waiting for, because we are not a separate blockchain, we don't have any particular goal in mind. And so basically, but the core question that we are solving is actually basically because we solve the networking problem. Networking problem is at the core of the finality as well. If you have a single entity, then finality is immediate. If you have more players, if you have more entities, they have to talk to each other, but the network is the key thing. So this is, I will stop here, I can talk more, but I'm going to leave to others to continue.
Thanks, and Aleksandar is the only one that I can give an excuse for not mentioning a number because everyone else is actually doing something in layer 1 or 2.
Hey, I'm Alex. I'm a co-founder of Near Protocol. Near Protocol is a sharded public blockchain with a huge emphasis on usability. So we're building developer tools so that people who are not familiar with blockchain can start building immediately. Starting with programmable language, which is TypeScript, which is on the intersection of what people can understand and what can be compiled to a reasonable virtual machine. And then we optimize heavily for people who are not in blockchain to be capable of using the applications built for Near. And that starts with us building protocol level support for contract-based accounts, for meta transactions, and other instrumentation that would enable people to use blockchain without distributed applications without being familiar with some hardcore blockchain concepts. And we're also researching heavily feeless transactions so that people don't have to purchase tokens before they start using applications and only purchase once they see the value of the applications. And the team behind Near Protocol is it's primarily coming from industry. It's ex-Googlers and a few very early engineers of a company called MemSQL, which is building a sharded database. Answering the question in terms of transactions per second, as a sharded protocol, the number of transactions per second until a certain limit grows linearly with the number of shards. So it is hard to give a single number depending on how many shards, depending on how many nodes actually exist in the platform. If it's a couple hundred and there's a single shard, it would be something on the order of hundreds of transactions per second. And then it would grow linearly with the number of people actually operating it. In terms of the finality is an interesting one because it has certain trade-off, right? You can have finality on the order of half a second if you build a completely centralized blockchain and call it decentralized, such as EOS. for as long as your blockchain is actually decentralized, you cannot possibly have finality faster than the consensus will be reached worldwide, right? The transaction is only final when everybody in the system agrees that the transaction happened, right? So for as long, it cannot possibly be faster than a single round trip from, let's say, China to the United States or from Russia to the United States. And that would be on the order of at least 1 to 2 seconds, right? So that's, no finality can be faster than that. Whether you can build a consensus algorithm that only does 1 or 2 round trips, that's an open question. Tendermint, for example, would probably reach consensus usually within 2 round trips multiplied by the agreement number of participants, right? So that's a question of how well it is organized. Right now, we're seeing it's within a couple of seconds, within a few seconds, that's the finality time per block. Would be interesting to see if someone can do significantly faster than that.
I'm going to actually summarize a little bit here that Aleksandar argued for layer 0 approach, that you solve the network problem underneath consensus layer, while Alex is saying that consensus is in some sense bottleneck, and we have to use shards to go around the problem of potential network delay. And maybe Thunder, who has more kind of hierarchical approach, can comment on that.
Yeah, my name is Wang. I'm CEO and co-founder of Celer, and we are building a high-performance public blockchain. And our blockchain is also we support Scalability, and we focus on making sure it's very, very easy for other people to use. So we make sure it works with almost all the tools on Ethereum. You could develop on Truffle, or you could use MetaMask as our wallet. And just when you develop on Truffle, you just need to change the deployment IP, and you could just deploy directly on our platform. And as for the performance, right now it's about 100 times faster than Ethereum. It converts transaction in seconds. It basically, it's convert transaction we get finality in about 2 round trip time. And depending on the network condition, we can get it turned down to in seconds. And so, yeah. And we believe that, it's important to, because we make it very scalable and we also convert very quickly, there's actually a lot of new applications now open up.
Let's move on to the other side of the panel.
Hi, I'm Vincent. I'm the co-founder and CEO of Redbelly Blockchain. And I'm also working as an academic at the University of Sydney, and I do my research at the Commonwealth Science Industry Research Organization in Australia. We've been working for quite some time on the Redbelly blockchain, so I can talk about this as an example of trying to assess the scalability of blockchain systems. It's very interesting, this question about finality or scalability in terms of finality, because I think there's a trade-off between the throughput you can achieve when you use a blockchain technology and the latency, which is the average time a transaction will take to commit. In our earlier experiments, back in July last year, in 2017, we deployed the Redbelly blockchain in a single country in the US, and we were using 300 machines at that time, and what we obtained as a throughput was 660,000 transactions per second. But we really maximized the performance of throughput, and we didn't really care about latency. That was our goal at that time. And then we talked to industry players, and we realized that latency could have a huge impact for their businesses. And so what we decided to do was to try to reduce the latency. At that time, the latency was more than 4 seconds, the average latency for a transaction to be committed. So what we did in October, which is much more recent this year, we deployed 1,000 virtual machines in 11 different countries on 4 different continents. And we ran an experiment, which I believe is one of the largest experiments of blockchain on cloud infrastructure. And we obtained an average latency of 3 seconds. And that was quite striking for us, because as you mentioned, there is a network bottleneck when you try to solve a consensus problem in a deterministic way. Essentially, we had to revise the consensus solution by getting rid of the leader, because our blockchain doesn't have shards, so it's just a linear set of blocks. But what we do is we make sure to have consensus before we have any block to the blockchain, such that finality would be ensured after one block is created. So essentially, we were quite satisfied with the result, because we also experimented on Amazon Web Services, and we observed that the latency between 2 data centers like Sydney in Australia and Sao Paulo in Brazil can be up to 300 milliseconds. So achieving a 3-second latency for 1,000 machines was quite satisfying.
Hi everyone, my name is Steven. Our team is called Harmony. Our mission is to really bring open consensus to 10 billion people, or hopefully 10 billion people in the future. We are very serious about the idea of decentralization. We do believe that being able to have 10,000, 100,000 nodes in the network is the key mission that we need to bring. After Bitcoin and Ethereum, we really want to be in the same league, bringing our original vision of 100,000 machines, really be able to operate at global scale. Coming back to the question, how to bring finality to all these transactions is a very hard problem. We do think that it's not just about the latency. People talk about block confirmation latency. Can really come down to about 15 seconds, it's not even less than 1 second to be possible. But the key idea is not just about block confirmation time. It's actually user-perceived latency. Can you actually, from the user, from their wallet, or browser, or mobile phone, all the way to the network, coming back to the user say, hey, this is final now, no one is going to change it, no government can revert it, is what people call user-perceived latency. Unfortunately, people actually be able to have block confirmation under a few seconds. User-perceived latency, even the best research in the lab setting, is only possible within about 90 seconds or so on. And that's why it's so challenging to make it happen. And also taking the short approach to the linear scaling to 100,000 machines, that's Harmony's mission. We do believe that that is the goal between the transaction volume, transaction speed, the number of transactions per second, the latency, and the fees that the blockchain will provide. And to us, we won't stop until we're at 100, maybe a few couple hundred milliseconds per millisecond for the latency. And it sounds crazy, but that's what many of the new technologies, whether it's 5G, 5G actually at 20 millisecond latency to the edge network. And we saw what IPFS is able to do. They actually do it with Cloudflare. We do believe that there's still a lot of work ahead.
Cool, thanks. Hi everyone, my name is Xiaozhou Li. I'm a co-founder of Celer Network. I'm a system guy. I enjoy building large-scale, high-performance and cost-efficient systems. So at Celer Network, we are building a layer 2 platform on top of existing and future blockchains to bring internet scale to every blockchain. So our goal is to really to scale the blockchain depth to like a massive scale. The thing is, if we envision a future, let's say with a global decentralized ecosystem where all people, computers, mobile and IoT devices can perform private, secure, trust-free transactions at large scale and massive scale, then we think the only relying on the consensus improvement of the layer 1 blockchain is not enough. We can never match the scale of the internet we have today. So I think in order to truly scale out the blockchain, we have to rely on layer 2 technology, which Celer Network is building. So what we build blockchain is like we use blockchain, the layer 1 public blockchain as a core, as a law enforcement, as escrow, but only use it as a last result. It's very like to our daily economic activity that you only go to court, only go to result to the law enforcement. If you are opponent, your counterparty cheat on you. So we are building this system that for all the devs, the flow of devs, for the players to co-sign and maintain their off-state replicated state machine, and only go to blockchain if something is going wrong. In this way, we can truly scale out and maintain a very good privacy for the users. And I really like the question they were talking about finality, not only about throughput that we were usually talking about. But if you think about the finality, if you think of the finality in terms of the dark business logic, actually layer 2 technologies such as the channel can achieve instant finality because their state can be considered as finalized as soon as your opponent co-signs your state. The latency is only bounded by the network latency and by the CPU latency. So in this way, we can really match the performance of the internet can scale out to millions, hundreds of millions, or even billions of transactions as long as the multiple players from the ecosystem and can achieve like milliseconds level of instant finality without making any compromise on the trust-free security guarantee from the underlying layer one blockchain. Thanks.
Hi everyone, my name is Xiaohan Zhu. I'm the co-founder of Meter.io. So I have a technology background, but before Meter, I was running an investment VC fund called CMK Capital. We have been started investing in blockchain and crypto since 2016, and actually some of the panelists here are our portfolios. But during this process, we've been just looking at what are the things missing in this ecosystem. What problems need to be solved for a truly decentralized financial system? That's how we decided to work on Meter. So basically, Meter has two goals. One is to create a stable unit of account that's native to the crypto world based on proof of work. The other target is to create a truly decentralized high-speed consensus. So these two things seem to be uncorrelated, but as you really dig deeper, you will find out if you properly design your consensus, properly partition your consensus algorithm, this too actually natural result of a properly partitioned system. So in Meter, basically we believe scalability should be unlimited based on the user's need and participants in the system. In terms of finality, basically we're targeting instant finality based on like every time we create a block, we create a final transactions. This is what's needed in a financial system. What we're at, basically we can only get there step by step, right? So at the initial approach, we're targeting not a crazy number, but like a solid transaction per second type of throughput and finality speed in terms of several seconds.
Right, so we have heard kind of three different layers approach for the scalability problem. We have obviously layer 0, and I think Alex and Stephen are using sharding so that you can overcome the underlying almost physical limitation of how much latency you have in the network, and consensus requires all the blocks to be delivered, so you're using sharding to overcome that. And I think we also have two mainnet teams, that actually 3, I haven't exactly heard Meter if they're for or against sharding. I think Red Belly Chain and Thunderpoint haven't exactly mentioned using sharding for the scalability. Maybe I'm opening a can of worms here, but anyone willing to comment whether you believe that sharding is the answer to our scalability problem, or sharding is just a nice complementary technology, but we should really focus on solving in layer 1 in consensus layer?
So I think short term, like today Ethereum can process 12 transactions, right? So assuming that sharding will take some time to implement, if anyone launches today something that is faster than Ethereum and is not sharded, that's going to be a huge win already. Long term, however, if we are expecting more and more usage of blockchains and more applications running on them, no blockchain that tries to process everything without sharding could possibly process all the transactions of all the services. Right? So from here, you would either have to run, let's say, blockchain per service, which is sort of Cosmos or Polkadot approach, but that's not very different from sharding to an extent. It's just sharding by the service. Or you would have to move as much as possible off-chain and only keep the actual slow chain for security of the off-chain solutions. Right? I don't think there are many other approaches to that. And so, but to an extent, you can also look at sharding as if that was a lot of plasmas surrounding one single beacon chain, which is the slow chain, right? With some modifications. So it's a closed technology.
I think another improvement can be made without sharding. I mean, for Thunder, we did not actually do sharding, but we are managed to achieve 100x improvements over Ethereum. And I think right now, one way to think about scalability, I think we should just solve one bottleneck at a time. And right now, I think the biggest bottleneck for Ethereum is in the consensus layer, and we managed to improve the consensus layer and achieve this performance. Now, in the long term, sharding in the long term it's necessary, but before sharding, I think there's still another improvement we could make before we have to use them.
Okay, you heard foreshadowing, kind of like, not exactly foreshadowing, I want to hear foreshadowing after that one.
Can you see?
So,
Yeah.
If I can comment on that, I would say that it's important to define sharding because it means a lot of different things. And actually, when I said that rapidly blockchain doesn't do sharding, this is true in the sense that we don't restrict the set of participants who can do transactions together. If you start restricting the set of participants who can do transactions together, then you would have to make sure that your use case or the application for which you build your blockchain will support this kind of scenario. Now, because if you would like to do a transaction across different shards, then maybe you will require some synchronization. There exist other forms of sharding, and sharding could be a subset of nodes that will run the consensus, or sharding could also be a subset of nodes that will do the verification for a single given transaction. And when we developed our blockchain, we realized that actually the consensus protocol was not always the bottleneck. And that was very surprising to us because we're distributed computing scientists, so we are not cryptographers. But actually what was super time-consuming and the thing that was affecting the finality the most was the verification of transactions. And so what we had to do is to shard the verification such that not every individual participant in the system will verify the signature of every single transaction. Instead, we restricted the subset. And you can see it as a form of sharding. And at the end, if you add multiple nodes, then you are adding multiple verifiers, which translate into lowering the number of transactions that should be verified by every single machine. And that was the way to gain performance. So there is sharding, but it's in multiple dimensions.
So, yeah. So basically, the way we look at sharding is you actually have to look at consensus from a different layers perspective. So actually, in all the existing cryptocurrencies, there are two consensus. One consensus is the value transfer consensus. Others transfer some value to Bob. The main focus of that consensus is basically prevent double spending and censorship. And this consensus is directly observable to everybody. There's another separate consensus is how much new value has been injected into the system. And in the proof of work system, this is done by miners' profit arbitraging behavior. And in proof of stake, basically, we're saying we're giving up on this consensus. We just focus on the first consensus, the value transfer consensus. And if you look at this, there's naturally become faster, but there's also different ways of optimizing it, right? So sharding is basically, we divide people into groups, and based on your zip code, we can divide and assign your transaction to different group of validators. So this is one approach. There's other approach like based on functions. Like if you're using this application, you are working on a sidechain or whatever. So basically, this is just natural ways of partitioning the system. I think it will just come naturally as the system scalability requirement goes up, but not necessarily to be exclusive of each other. If you look at our society today, basically we have that zip code system, but we also have like a function-based system. At the end of the day, it's a matrix of the structure of the to form our current enterprise system. So we believe sharding is needed, but it's not the only solution out there.
I actually would argue that one of the slowest things, that the reason the consensus layer often becomes a bottleneck is because of state transition that comes from the smart contract that needs to be verified that delays the entire consensus layer. Maybe Stephen, are already sharding smart contracts? Maybe you could comment on that.
Sure. What you mentioned about sharding, coming back to smart contract, is really a great way to look at what to shard. There are three things to shard: the computation, the state that you need to store, and then the communication, who is talking to each other. And why we are crazy about sharding, and I'm for sharding as well, is because how to answer your question, all these smart contracts, how do we scale it faster? The key question is, I know EJ is interested in machine learning. There's no way to do machine learning on blockchain if you don't shard the computation. Only someone needs to run the model and train it and infer it and verify it should be able to. Whether it's about AMP problem verifying polynomial time, or machine learning problem that you can easily check whether he's using the right model, the computation has to be sharded. Coming back to the state sharding problem, if you talk about thousands, if not even million transactions per second, we're not even close to what Facebook and Google allow us to build application today. We are literally talking about a terabyte of data every day. So without thinking about how to do state sharding, there's no chance of answering the question of which smart contract I can run. But then I think many people here at the panel at least is already thinking about the communication sharding already. Many of them are doing the routing, layer 2 solutions. We have to figure that out because at the end of the day, communication turned out to be the slowest right now. We're still not running the machine learning on blockchain, but we are communicating. And for Harmony, we do want to stay with 100,000 nodes. We already on the benchmark with 44,000 nodes. Without communicating faster, whether in layer 2 or better routing, there's no way to solve what you asked us about how to scale smart contract.
I'm sorry, if I can just, it's going to be very quick. So I believe that we are losing the audience. We are getting too technical. And my rule of thumb is if you can't explain something to your grandmother in 1 minute, it's not going to fly. And this is basically my biggest concern with sharding. It gets too complicated, and if something is hard to explain, then it's even harder to implement. That said, we support we are basically compatible with all other projects out there. Sharding works, we are happy, they're going to create all the work for us, and we are compatible with all these projects. So that said, I look forward to hearing more from the left side.
I would like to my thoughts on sharding. So though Celer network has two solutions that focus on this layer 1 technology. But me myself, I did a bunch of research work on distributed key value storage database before. Sharding is the keywords of my daily life. So I know that sharding is a very powerful and not new techniques to scale out distributed systems. And I really like to see sharding can be applied to blockchain to scale it out. My only concern is that when I used to apply sharding the system, it's usually the first assumption, the principle is that the data, the computation is very easy to partition. Those you can partition all the data computation to not that closely correlated blocks. Then with sharding, you can do like a really amazing scale out system design. I'm not sure if we already have that like a good design to partition all the information, the storage, the computation right now. So I really would like to look more into this if we can do better, especially the performance when we encounter like a cross-sharding communication set.
I totally agree with that comment that enforcing sharding without having a central authority is going to be definitely a challenge in the blockchain community. With a little bit of time left, I'm going to ask a different scalability question. I think one of the rising problems in the blockchain community is that as we're getting popular and we have more blocks to process, verifying or validating, as Vincent was mentioning earlier, that a new transaction is a valid transaction is becoming more and more of a challenge, especially it's increasing the entry barrier for the newcomers, whether they are validators or miners. They have to go through 5 terabytes of data to make sure that a single transaction is a valid transaction. This is a scalability problem that we are starting to experience as of today, and I'd like to hear your thoughts about how we should approach this problem.
So I think the person who would be the best to answer this question is not here today. That would be someone from Coda, because Coda is solving exactly that problem, right? They trying to compress the entire blockchain using a single cryptographic proof. The problem that the cryptographic proof they use is called ZK-SNARK is super slow to compute, and the entire idea of Coda is actually how to figure out how to parallelize this process.
So are you the Coda certified? Can actually poke you a little further between Coda and Stacker? You're on the side of Coda team?
Between code and what?
And Starkware.
And what?
Yeah. So basically, either you snark or start is another question.
Oh, I see. Start. It doesn't matter at the end of the day. If you can prove, right, so it starts and that's faster than snarks, I'm sure code will start using starts. That is our token, right? But I think ultimately we will either have to do that. So effectively, once snarks become sufficiently fast or starts become sufficiently fast, we will all switch to proving the history of the blockchain, or we effectively have to somehow trust. Like one way would be if we assume that we use Byzantine consensus and every validator set was honest, we can just assume that the last block is correct. Like Algorand is making this assumption, for example, right? Or alternatively, we can have trusted snapshots. We can say, like that's how people use Ethereum today. Nobody downloads 2 terabytes of data. People download the last snapshot and we just trust it's correct. Right?
I would say that the snapshot idea is similar to what Vincent was mentioning as a different kind of charting that we only need to do from the intermediate state.
Yeah, I mean, in our system, when you start a new node, you don't actually have to compute from the very beginning. You could just download a sort of a snapshot of the state from another node. And then, but you also don't have to trust this node because you could just verify that the hash is correct. And this hash, you can actually just verify that all the nodes have the same hash. So you know that you have the most recent state. And this actually just solves the problem of just, downloading from the beginning.
Yeah, it's true that if you have small mobile devices or you cannot afford to store a very large amount of data, then the blockchain storage space may become a problem. But you can also do things differently, especially if you are looking at the Byzantine fault tolerance model, where we all know that consensus cannot be solved if more than a third of the processes are malicious. Then you can simply make sure to retrieve the information from strictly more than a third of the processes, to make sure that you have a copy that comes from at least one correct process. And by doing that, you retrieve the correct state of the blockchain from which you can infer the validity of the transaction it contains. So that's also a way to bypass the limitation for small devices that don't have the storage capacity of bigger machines that would play the role of the miners.
Do we have time for Q&A? All right.
So for Meter, basically we take like a sidechain and root chain type of approach. So like Chris mentioned, you don't really have to compute everything, compute all the states from the beginning. So you can download just from the other participants in an hour on each chain. So basically, because we have a multi-chain type of approach, so each chain will just take care of its own storage. So we kind of address the storage problem that way.
So again, this is not the most concerning problem of Celer because we are layer 2 solutions. I think honestly we don't have a good answer to which is better. Essentially, all well-designed distributed systems all come down to different trade-offs, trade-offs of computation, storage, security guarantee, privacy. And someone prefer different trade-off decisions. So as a layer 2 platform, what we can do best is to provide good programming models as good solutions to adapt to different trade-offs, like to whether storage costs more or computation costs more. And for different trade-offs, we always provide the best underlying systems to support this trade-off preference. Thanks.
Just so that Harmony can have the last word. We do think that what you said about sharpening the computation is super important. But Harmony really believe that out of the current theory, sticking to the vision of 100,000 nodes is far harder to solve. And really it is the communication problem, whether it's about data availability, how to do all the layer 2 routing and so on. That's why it's so hard to solve 100,000 machines talking to each other. The computation of machine learning over different nodes and someone just verifying it, or the state, whether the sidechain node can be solved with many of the smart data structure, but the physical limit of the data communication is just the hardest that we want to solve.
All right, please thank our panelists for sharing.